The multiplication of complex numbers is written as Z1 times Z2. And with most algebraic operations for multiplication, we can simply leave the multiplication out and we just write it as Z1, Z2. Now Z1 as a complex number can be defined as X1 plus I, Y1, and Z2 is equal to X2 plus I, Y2. So we want to find some rule for multiplying Z1 times Z2. So if we just write Z1, Z2, we'll do a substitution here for Z1, which is just equal to X1 plus I, Y1. And then we'll do a substitution for Z2, which is X2 plus I, Y2. And like most algebraic multiplication, we use FOIL. FOIL is first, outer, inner, and last. So the first, as we multiply the first two terms in the bracket, I might make a bit of room there. So if we multiply x1 times x2, we get x1, x2. Then we do the outer. So this will be this one times this one, so that's outer. So that'll be plus x1 times I, y2. The inner are the innermost terms in this multiplication, so that's plus I, y1, x2. And then last is the last of each of the brackets, so that'll be plus I, y1 times I, y2. So we use FOIL, and that comes up with this expression here. The next step is to try and simplify this, and x1, x2 can't be simplified anymore. It's common to put I at the front, so we'll do plus I, x1, y2, and we've already got I there, I, and we'll put the x2 and y1 in that order, so to keep it in line with this. Now this is a little bit, needs a little bit more attention here, because we can put the I times I and get I squared, and as you know, I squared is equal to -1. So I times I being I squared -1, that positive becomes negative, and we get y1, y2. So going through this last little bit here again, if we multiply that I times that I, we get I squared, and by definition I squared is equal to -1. So the -1 simply makes that plus into a negative there, and then we've got y1 times y2. We need to reorder this now to get the reals all together. Now the real ones are x1, x2, and then this is a real, this does not contain an I, so we've got y1, y2. And then the imaginary part of this result here of the product is the combination or the addition of these two terms. So it's plus I, x1, y2, plus I, x2, y1. So once again, we can write it in real and imaginary terms, x1, x2, minus y1, y2, plus I can come out the front using the distributive law, x1, y2, plus x2, y1. So this is a real part of the product, and this bracket here would be the imaginary part of the product. So we probably need to do an example to show how all that is put in place. So if we've got, let's say, 2 minus 4i times 5 plus 7i. We can write, use FOIL straight up. So if we multiply the first together, which is those two, so 2 times 5 is 10. The outer, which will be 2 2 times plus 7i, and 2 times plus 7i is plus 14i. So we've done first outer, then inner will be minus 4i times 5. A negative times a positive is a negative, and 4 times 5 is 20, so that'll be negative 20i. And then the last is negative 4i times plus positive 7i. Now, a negative times a positive will be a negative. 4 times 7 is 28. So we've got negative 28, and then you've got the I times the I. And I times I is negative 1. So we actually get plus 28. So just going through that again, when we do the last, you've got a negative times a positive, so we get a negative, but the I times I is negative 1, so a negative negative becomes a positive, and then 7 fours are 28. So we get plus 28 for the last one. Rearrange this to combine the reals and the imaginaries. Here's a real, doesn't contain I, so we can get those two together. So I've got plus 10 plus 28 is plus 38. And then we've got plus 14i minus 20i, plus 14 minus 20 is negative 6i. So when we multiply that out, we get 38 minus 6i.